I'm pleased to be physically hosting you in a physically co-located in San Francisco edition of Computers, Coffee, and Beer. This time, no coffee, no beer, but all computers.
Decaf.
Decaf coffee, I guess that counts, that counts. It's a pleasure seeing you, my old friend.
Very good to be here.
Yeah, thank you for being here. There's tons of stuff we could talk about. We're physically here in Pebblebed Intergalactic HQ in San Francisco's Mission District. We're investors who build. You're the CEO of Skip Labs. You got a million things going on. But our default equilibrium over the last couple decades, as a aficionado of programming languages and a programming language professional, usually talk PL. And one of the things that I find myself really confused about these days is what it means to do programming language research or to build new programming languages in this kind of post-LLM world, right? Because I've made sense of programming languages as an intellectual discipline, as a kind of applied psychology so far, right? You're bridging this gap between these very inhuman machines and the kind of limited psychologies of human beings, and we have our strengths as well. And you're trying to translate those strengths of humans into these machines. And now a lot of the code is going to get written by very different psyche, it seems like. And does that change PL? Should it change PL? Does anybody know?
I think nobody knows. Let's start with that.
Okay.
Then I think there will probably be different phases, right? And I think phase one, what's going to matter is going to be where's the data coming from. So right now you see an uptick in TypeScript, for example, and that's because LLMs are very good at TypeScript. And then it's this virtuous or vicious circle, depending on how you want to look at it.
Positive feedback loop, one way or the other.
Loop, where the more code there is out there that is written in TypeScript, the more AIs are going to pick up that data and are going to be trained on that data, and the more there will be TypeScript out there. Now, the two languages that seem to be really doing well with LLMs are Python and TypeScript. I could see how I think TypeScript is going to win that race. And that's because TypeScript is faster. It has a JIT that makes, the execution kind of reasonable.
I've been briefed, yeah.
You've been briefed.
Yeah.
You heard about this JIT.
This JIT stuff's going to be hot. You heard it here.
And the other thing is that it has somewhat some tooling around types. So there's a culture of typing. TypeScript is not sound, so that means there are a lot of things that you cannot do, but you can still describe intent in terms of types a lot better than you would in Python.
Right.
And those two will, I think, give enough an edge to TypeScript to beat, to win that race between Python and TypeScript.
I mean, do you think that's the equilibrium, is just sort of TypeScript eats the world? And
I think for now, yes. As long as LLMs need a lot of data to be trained, I think TypeScript is going to eat the world. But it might not stay this way forever, because what's going to end up happening at some point, I think, is that LLMs are going to become good enough at programming in general that the programming language probably will not matter as much. And when we get to that point, that's when things are going to become really interesting.
So one of my dreams here, if I may, because I'm impatient to start banging this drum, is why hasn't this made a big fluorescence in C++ and other kinds of machine-friendly languages, let's say, right? Because if your story, the sort of age-old push-pull inside of a company was always sort of C++ versus your programmer productivity languages. And the programmer productivity language people, right, the people writing PHP or the people writing Python, the people writing TypeScript these days, or whatever your kind of productivity-oriented language is, they do lay a lot more track than the people sitting there kind of, puzzling over 20 pages of template errors and a compile failure, right? But if I'm an LLM and I love type systems anyway, right? Type systems are just sort of awesome feedback for me. I eat them for breakfast. Why not also do something that's generating amazing machine code the first time, like C++?
It's a little bit of a mystery to me. I think it really boils down to data that isn't source code. So I think basically, and I'm just speculating here because it's not my job to train these things, but I would imagine that what's going to be very useful is annotated data where you have small snippets with somebody explaining what this thing does. And, with something like Stack Overflow, most of the data was related to TypeScript and Python because these are programming languages where you can actually program this way,
Right.
where you're trying to put something together quickly, you need feedback, you don't know how to do something, you type it in Google, then Stack Overflow, well, now you probably use ChatGPT, but back, pedal back, 10
Daddy,
years.
what was Stack Overflow?
Exactly. And so there's probably someone on Stack Overflow who already discussed that, and there's a snippet of code that you can copy paste, right?
For future listeners, possibly on a lunar base or whatever is going to happen in the next 18 months, Stack Overflow was a site du web. It was a HTTP service where people would ask questions, usually about the programming problem they're having, and there was like a social gamified aspect of like trying to answer lots of questions, and so people would compete to have highly ranked answers to these questions. And so you would Google for, the problem you're seeing, or message you have, or the thing you're trying to do, or something, and there'd be some little snippet of like, oh, here's how handled this edge case in parsing YAML and blah blah whatever.
Exactly. So chances are very high that if you're trying to do anything in JavaScript, you basically type it with words, and there will be someone who is going to explain to you how to do it and give you a snippet of code.
Right.
And I think that is going to be much harder or impossible in C++.
Right.
Because if you program this way in C++, it's never going to work. Right? I mean, it's probably going to be worse than that. It's going to look like it's working,
Yeah.
and really it isn't.
Yeah.
I've seen that a lot where, when you watch somebody experience in C++, review C++ code, and every single line they're like, "Meh, undefined behavior, undefined behavior." Oh, I see another undefined behavior right there.
Right.
So if I had to speculate, because then again, I was not involved in the process of training those things, I would imagine that it has a lot to do with data on the internet that is available to train the model.
I mean, these days I do have a bunch of, like a lot of other people, right? I spent, last winter finishing all my side projects in GitHub, basically, right? And being blown away that Opus 4.5 could do it. It's gotten a lot better since then. It wasn't that long ago. Definitely, they're pretty good at writing C++ now. And I think one of the things that I was surprised at, my shrinking margin, my shrinking little island of like stuff that only Keith can do with computers or whatever over the last couple of years, a lot of the stuff that was defended there until then was lock-free data structures in C++. Do you know what I mean? Like trying to do correct stuff with std atomic, where it really is concurrent and it really is a state machine. I think until like about Opus 4.5, it was as if the LLM didn't really think about concurrency. It would sort of write a serial version that would work, and it like just clearly wasn't really thinking about races or anything or hazards or anything like that. It does all that now. It does all of it sort of reasonably marvelously. Like there will be bugs. You do have to review it. Uh, but it's more like, a colleague a pretty senior colleague on your team, honestly, right? Because like none of us write defect-free code. A sort of defect rate of human-written C++ is estimated at 1 every 10 lines. It feels higher to me, honestly, than one line in 10 that's a defect. And so even for the data poverty, whatever's going on with sort of abstract reasoning and RL, and maybe some of these companies have big C++ corporate that they don't share that make this easier. But I'm pretty impressed if you'll grant me my premise, basically, right? Like grant me my premise that this generation of LLMs is also awesome at writing C++. So it could.
I think there's a big difference between writing from scratch
Yeah.
and modifying something existent,
That's
right?
true.
If we're talking about writing something from scratch, Python and TypeScript are just really a step above.
Yep.
If you're talking about looking at an existing code base and modify it, LLMs good at a lot of languages. You can use them to do a lot of things. But really, from scratch, I would go with TypeScript or Python. And also, depending on the size of the project, that has to be dealt with from scratch. So, for example, if I had to write one function in C++, that would work really well.
Yeah.
If I had to tell the LLM to write me an entire project with, let's say, 10,000 lines of code in C++, what I've seen is a big difference between a project, even with other languages like Go. It seems to be working a lot better in TypeScript or Python.
Yeah. And you may have tried more things than me too, but That's interesting. I actually thought you were going to go the other direction with this, that it's like the big existing project that it struggles with. But
No, I mean it struggles with it struggles still with understanding what the large project is doing, and also it can introduce really subtle bugs because it doesn't understand the environments of the bigger project. But this is all a given. But I was more saying it's not so much that LLMs have a good time or hard time working on big projects. It's more like the comparison between the difference in performance between TypeScript and C++, you can see it a lot more on a project from scratch.
So let's imagine that you're right. You're right about this. I find it's pretty persuasive, to be clear. This is like matches my experience as well, as it seems just want to write TypeScript and Python to some extent. They divide up the pie between them, right? Like most new projects get built in one or the others of these languages, unless you've got some burning need to build it, to the metal for some reason. Do you think TypeScript evolves in ways that are LLM dependent? And if so, what are those ways? Right? Are there things the LLMs like wish they had in the language, so to speak?
I think it will get to that.
Yeah.
I think it will get to that for many reasons. The first one is we're going to run probably into security problems. Um, TypeScript already has security problems. I mean, JavaScript community in general already has security problems because there are a ton of packages out there, and they're evolving very, very fast. And it's a culture of programming that's very different from C or C++. It's a culture of programming where taking on new dependencies is not frowned upon. Like when you're writing a C project, every single dependency is very carefully thought about, and C++ as well. And that's because the interaction between those libraries and your own code can lead to very subtle bugs and can lead to things that are very difficult to debug and maintain. And so that's why people are very careful about those dependencies. In the world of Python and TypeScript, not at all. Like whenever you need something, just install the package, and then that package installs another gazillion packages. And before you know it, you depend on a ton of code, and some of it is vulnerable. And I think what's going to happen is that this problem is going to become exponentially larger for two reasons. One, we're going to see a lot more code, and the LLMs will also have that kind of instinct. They will install whatever they need to get this stuff.
That's what they've seen, right? That's what they've learned to do to get functioning
And
programs.
number two, we see models, especially like ones like Mythos now, who are really good at injecting, finding security holes, injecting them. And people are going to use that to find new holes and find new ways to, hack into the system. So I think just for that already, the system will have to evolve because there will be pressure to maintain that ecosystem in a place that is sane, to bring in tooling and guardrails for those systems.
So let me try and interrogate this I have two completely opposite and incompatible with each other reasons that might not turn out to be the case, right? So in one scenario, almost everything about the way the software world is set up is there to maximize code reuse, because the prior is software is precious, right? It took the sweat of some poor programmer in San Francisco's brow to get this thing to work in the first place. You'd be a fool to think you can do better in most instances, so don't. You just import the thing, whatever. In a world where software is not cheap, or software is not precious rather, and where you can throw everything out and start over again whenever you feel like it, why all the code reuse? Like why not make a little JSON parser when you need to parse some JSON, and why not make a little YAML parser when you need to parse some YAML, and so on?
Still cheaper to share. It's like imagine I made the same argument in programming. Right? I told you, you know what, RAM is cheap. Why reuse some things that you've computed and not just so obviously there are trade-offs,
and output tokens do cost something, it turns
exactly.
out too. So yeah.
So true. I think there are trade-offs. There are cases where there are these algorithms on sat solvers and things like that. And I used to be really interested in those in the early 2000s, and my instinct as a functional programmer was always, well, these things need a lot of backtracking, right?
Yeah.
So it needs to try something, and then once it's tried, it needs to go back into the state where it was to try something else. So it's like, obviously, you should be using persistent data structure for this stuff. And I tried, getting some of those algorithms like, Davis-Putnam and these kind of things to work with functional data structures. And it was way, way, way slower
Yeah, yeah.
undoing the work you'd done
Right, and just redoing it.
and just redoing.
Yeah, yeah.
And the other, well, minus one basically of your operation and then go back to try something else. Super frustrating for me. I was like, so really this whole persistent data structure makes, making checkpoints cheap is, yeah, it's cool in theory. I mean, no, there are some places where it works really well, but there are some others where the trade-off is just not good. So I definitely think that for LLMs and code, there will be things like that. There will be moments where the LLM thinks, you know what? It's going to be too complicated for me to figure out how to set up this or that. So let me just regenerate the code that does this. But in general, no, I think you still want to share code because tokens are not free. They might be cheaper than a human being, you know, typing things with their little fingers, but they're still not free.
Yeah. There's and then I guess the opposite, I think you're right, probably, right? I think there's one of the things that people seem to get confused about when talking about artificial intelligence in general, especially sort of extreme extrapolations of it, right? Like way better AIs than we have today, is to assume that just because it's very smart and perhaps also very plentiful and getting more plentiful, that it's literally free. You know what I mean? Like there will always at least be the energy required to run the model and so on. And so you will have to kind of outbid the other users of those resources to get your thing through. So there still is going to be an economy of effort, even if the intelligence is way, way better and way more abundant than we can imagine right now. So I think it's still going to matter to save effort. And for that reason, there will still be code reuse just because like reusing solve problems is useful to artificial intelligences too.
At Slack, so you guys had a hot conversion.
We did. We went through. We did go through a. So Hack kind of is to PHP as TypeScript is to JavaScript, if you'll allow me to say so.
Yeah.
Although you got there first, for the record, because you're probably too modest to say it. But as a gradual typing system, that's sort of oriented around how PHP programs tend to be written. And Slack, a little bit like Facebook at the time I started, was a grown-up LAMP stack app. Was a Apache MySQL PHP. One of the founders, Cal Henderson, had a bunch of success with that at a previous startup, Flickr, right when the consumer photo sharing site on the internet. Basically saw no reason to change that. And around the time I started as chief architect in 2016, we're starting to see some of the.
Wait, chief architect. I love these titles.
Sorry.
I love these titles.
Yeah.
I'm gonna. Can I call you chief architect from
I'll
now?
allow it. Yeah, I'll allow it. You've earned it.
I love those titles. It makes me think of what religion is this? Is it Franc-maçon who have that? The Freemasons, the big architects, and so it reminds me of that. So that's why I always find those titles funny. But please,
no, it's fine. I grew up in a Marine Corps household, by the way, and like the modifiers you put in front of like enlisted ranks pile up very similarly to the modifiers you put in front of individual contributor titles, basically, right? Like you're a staff engineer. I'm a staff
yes,
sergeant,
there's that too.
Senior this, senior
Can
that.
I be a public static staff engineer?
Yeah, can you be a senior staff chief? Whatever, right? So I mean, the way that we've when that offer came through initially, like me and Cal kind of sat down and negotiated like what that meant in the context of Slack. That can mean different things in different places. And when we kind of like workshop this definition that was like, I'm accountable for Slack's technical strategy, right? So I'm accountable in the sense that like I'm prepared to give account, right? Like there are other parts of the company that want things, and when things break, I need to be able to articulate what happened and what we're changing. And then the technical strategy part of it is like I need to be kind of aware of what the heck we're trying to do, what business challenges we're trying to address in the medium term, and have the tech roadmap at least align with and hopefully anticipate and improve that course of action. I'd say like in hindsight, I give myself like a B minus or something. I think like I didn't I don't think I drove the Ferrari into the ditch completely, but like there definitely are things I would do differently. But the hack conversion, since you're asking the PL question, I don't know if we've like ever sort of gone blow by blow through much of this, right? around the time I was starting in 2016, some of the problems that you tend to run into in big PHP code bases were starting to show up, right? And
So how big was the code base?
good question. Order of a million lines, right? So in the 100 to million order of magnitude, I'm confident.
And it was running HHVM already, or
It
still?
was running PHP. It was running Zen PHP 5. I think we were stuck on 5.3 at the time, 5.4 maybe. Um, and uh, and changing PHP versions was a whole thing, and so on. So if you've never worked on, and I guess people these days like might have had their whole careers kind of in a TypeScript code base or something like that. If you've never worked on a big, entirely dynamically typed code base, it's really, really daunting, right?
If you've never done it, good for you.
Yeah.
Good for you. You should be happy about it.
That's right.
and,
That's right.
and strive never to have to do it. But yes, it's daunting.
So let's say, for instance, the code base sort of 9 times out of 10 does the order of arguments, user ID, then permissions object, then, object you're acting on or whatever, right? And there's just like some place in the code base that did it some other weird way.
What
right?
about test coverage? Because
Yeah.
usually that's what determines if it's possible to work in a big dynamic language code base. So how was the test coverage?
Test coverage, I think around the time we were talking mostly in terms of line coverage. It was order of 20%, and we had sort of a continual like quarterly OKR around increasing test coverage all the time. This ended up sort of making me cynical about the sort of Goodhart's law properties of tracking that metric too closely, right? So Goodhart's law, of course, right, is like when you attach incentives to things, it stops being a useful metric, right? So if we start attaching sort of the proxies of success, including like raises and, getting pats on the head from people you respect to test coverage, well, one way to cover the code is to like have all unit tests just be a trace of the implementation, right? Like,
people are going to game the system.
Yeah. So that's the thing is like, that'd be one thing. It'd be one thing if people are cynical and they're just like, I'm just going to get my bonus and blah, 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 and write these bad tests. That's actually not what's going on. I think it's actually a more subtle thing where if you sort of drop testing culture on an engineering culture that hasn't had it before, people are like, okay, we're supposed to write tests. And they don't really have like I guess the sort of interior model of like what's desirable about like what makes a test good or bad.
Well, I think there's that, and there's also the tools that kind of shape how you see the world and the programming language as well. So this is, I've sorry to go on a tangent here, but
great.
I've been in these debates a million times, right?
Sure.
You've got a dynamic programmer who tells you, well, I don't need a type system because I don't make typing mistakes. And anyway, I write the tests, I have to write tests, and the tests are going to catch the typing mistakes that I would be making. So really, the type system is kind of wasting my time.
Right.
And, to somebody who comes from a language like Java or C++ or whatever, that seems to be incredible to hear. You're like,
literally not credible, right?
Literally not credible. They're thinking, you are lying to me. Like, you need a type system. I use it all the time. It catches mistakes for me. And the thing is, the tool that you use shapes the way you think and also the way you see the world. So if you are using, a dynamically typed language all the time, what is going to happen is that that things are going to fail all over the place, and you will write code with tests that are very defensive. So you're going to really test everything. And if that's your style of programming, and I give you Java, you're not going to change your style.
That's right.
So you're going to write all these unit tests, you're going to check for all the types of everything. And then, what you're saying about Java, which is that the type system is a pain in the ass that gets in the way, is true for you because you're actually in the habit of writing all those unit tests, right? And the same is true the other way around. So if you take somebody like who comes from a statically typed language, they're used to not test the types for the input parameters or things like that, because all of this is checked by the system. So they come into Python and they don't change their style of programming, and they realize that, things break all the time and things don't work the way they're supposed to. Yeah. Now, I would argue that in a large code base, there will always be a large enough fraction of people who are not disciplined enough that every dynamically typed code base I've seen is bad.
Yeah.
Like I've seen small projects where this works because they're disciplined enough to make it work. But in larger code
virtue
base,
doesn't scale, right? Like just saying like be a good person, care a lot about the code being right, like that. You can't enforce that in a huge organization.
and I mean, I've seen that in other places too. You know, there's the functional versus OO stuff. So I've seen that a lot where you see people fight because they see the world in different ways and they don't realize that the tools that they use and the problems that they use to solve has shaped their understanding of programming. Another good divide is system programmers versus non-system programmers. So let me give you a few examples. So if you are a system programmer, you see the world.
Recovering systems programmer.
Yeah,
recovering. Yeah, carry on.
You see the world through memory, right? Like what you see in your head when you're programming is memory, because the memory layout is basically everything. Like this is what you have to care about, because that's how you're going to write a driver. That's how you're going to write a garbage collector. That's how you're going to write all that stuff, you know, or a kernel, all this stuff. You need to know exactly how memory is laid out. So that is what you see in your head when you're programming, right? And so now somebody comes along and tells you, yeah, we're going to abstract that all away. You know, this is going to be called Prolog or Haskell. And you just, you know, define what you want it to do. And then the system programmer goes like, that's not programming. Like, what does this
is vice? Yeah, exactly. Like this is wrong. It feels
what
like
does this do?
Yeah, nobody can tell me like what machine instructions correspond to any of this. Like,
and so the system programmer comes in and you give them a problem, and what they're going to do is think in terms of memory layouts, and then they're going to structure things this way, right? And so if you give them a garbage collector, they're like, this is already too much, right? I want to know more. But you see that divide also with functional programming versus OO programming. So, for example, to a functional programmer, everything is about types. You need to know the types of things, and that's what's going to shape your understanding of the program.
Right.
Once you know the types, once you have the signatures of the functions, the functional programmer kind of feels like, yeah, this is my understanding, my abstract understanding of the program.
Right.
Except that there are different ways to abstract the same program. So in the OO world, they don't care about types. They care about functionalities.
Right.
So what they want is they want to know, what is the API? What can I call? What can they do with this thing? But what the shape of this thing is doesn't matter to them. That's abstracted away. That is. And so when you see those two kind of people trying to basically they switch to a different world, you see exactly the same frustration. Right. So the functional programmer arrives in an OO code base and is like, what is the type of this? Yeah. You know, what does this program do? Like, I'm calling this method. I don't know which method I'm calling.
That's right. Like, what its inputs, what its outputs. It's
I don't know what's going on here. Like, help me, you know? And the OO programmer is totally cool about it. It's like, no, but you don't need to know what's calling. You just need to know what it does, you know? Right. And the other way around, right? Like you've got the OO programmer who shows up in a functional code base and who'll have similar frustrations. And what is very interesting with all these cognitive biases that come from the tools you're using and the language that you're using is that I've rarely seen any programmer who understand those biases, who consciously aware of those biases.
Yeah, like you can know this the same way you conceptually know about yourself that you have other cognitive limitations, but then you go out and just like enact in those cognitive limited ways anyway.
Exactly. So what I've seen is, you know, the C++ guy who really thinks that everything should be written in C++, and anybody who doesn't use C++ is an idiot.
Right.
And it's just no.
We call those people correct. Right? We call those people who can program, people who actually know how to program and know how computers work. Right.
I mean, system programmers are really interesting because there's also some kind of hierarchy of, you know, how noble the software is.
Yeah, the less feedback you have, the more.
So no, I think it has to do with the execution stack, which is that if I'm using software that you have written on a daily basis, but not the other way around. In the software hierarchy, that makes you more important.
I'm a worthier person. I
Or
agree.
at least that's how system programmers see the world.
That's right. That's right.
And so for system programmers, they're thinking, well, I write the kernel, bitch. You know, I'm the man, you know, like, what are you doing? Everything you do uses my stuff,
That's
right?
right.
I don't care about it. And so it's really interesting, those hierarchies. That there's also the
I'm sort of a reformed kernel person. Like I expected to end up doing kernel stuff.
So, for example, for kernel persons and system programmers, one thing that drives me absolutely crazy is how shitty their fucking APIs are.
Yep.
Sorry for my French,
No, it's fine.
but basically, it all comes back to it's for good reasons. It's basically what happens is they optimize for speed, for memory consumption, for basically the hardware.
Yep.
They don't optimize for the human. Let's say you're in Java. If I take a library in Java, I look at the name of the methods, and I read the docs quickly or whatever, chances are high I'm going to get it right without reading all the
You'll know
docs.
whether this is a game engine or a trading AI thing or
I
something.
mean,
Right?
even going that we can go more into details, but let's say I have a method that starts a process.
Sure.
I assume that if I just call this method without any of the optional parameters, it's probably going to do the right thing, right? And in system programmers APIs, it's almost certainly never going to do the right thing. So you've got two annoying ways. You've got the one where you're trying to do something very simple, and 99% of the users will try to do these very simple things. To get that simple thing to work, you need 25 different calls and setting up, and everybody copy pastes the same code that they found on the internet to get that set up. So that's create process in Windows, for example, if you've ever used that.
ioctl and like the family of ioctls on Unix, right?
And the other example is the API has just all the wrong defaults. So for example, I discovered the last instance of that was I discovered recently, not that recently, maybe 10 years ago, that you could now use locks within shared memory.
Right.
So this used to be something completely esoteric that nobody was doing, was definitely not supported by the kernel.
You guys aren't doing this, are you? You're not doing this. Sounds really scary.
We're not doing that, but you can do that, right?
Good to know.
And so,
this is System 5 shared memory segments that we're talking about, and which is like a little bit of a wart on the Unix API to start with, arguably.
Well, yeah. And now you can tell at the initialization of the mutex that this is actually in shared memory. And so if you have different processes that mapped that same part of memory, they can actually use that as a lock.
Okay.
And so this is now supported by Linux.
This is via mmap, not via System 5 shared memory, or
it's system shared memory. So it's an mmap.
Map shared, but not the special funny namespace that's not the file system. That's the shmem calls. Okay.
No,
sorry, I'm showing.
No, it's not that. It's just a regular mmap.
I'm so relieved. Okay.
Regular mmap with shared. I misunderstood what you meant. So regular mmap that is just shared, that you can share across different processes. And it used to be that if you try to allocate a lock in that memory, the lock was basically not working, right? And so now it's supported, and it has been supported for a long time. So I was very happy about that because I needed that. And I, do the stupid thing, which is like, I did not spend my whole day reading the man page. And, like the system programs were there to punish me because they don't like that.
That's right.
You are supposed to read the whole man page.
That's right.
And read it multiple times.
Is the ETLA for this.
And I didn't do that. And then, so what I would expect is if one of the program crashes, one of the processes crash, it releases the lock.
Right.
And it doesn't do that by default. Of course not.
Yeah.
Why would it? Why would it do that by default?
That might not be the safe behavior. Maybe it needs to still have exclusive access until it restarts.
And I mean, when you think about it, what probably happened is that it probably costs something extra to do that extra work when the process is killed. And so they decided to not make that the default for those who want. But it's fucking stupid. That's not what people want. And so to go back to how system programmers think, they do not think in terms of what do the people who are going to use my API want. They're not thinking in those terms. They're thinking in terms
I
of
think that's the library author's problem. Seriously.
exactly.
Like that's actually how you do think about this. Is like you because I've been in the position of having to build these horrible systems that you're describing in various ways. And like the thing is, like, you never get performance back if you give it away, right? Like there's no lever that lets you like be like, oh whoops, be like this inevitably, and it's like a store, right? Maybe it's literally one instruction, but the semantic of the way we define this means we just absolutely have to do this work in this situation where lots of people don't need us to do that work. And so you want to say, okay, it's all a library's problem. And I mean, I am one of these people that you're talking about, obviously, first of all, right? And I grew up in kind of, you were educated in OCaml. I was kind of educated in C, not because that was how those countries were doing it at the time, right? Like you just.
So I started with C actually.
Oh,
my
okay,
first language was C and Pascal.
Oh, great.
And
Yeah.
I discovered
So you understand how computers work, and
I
yet
I understand how computers
you have
work.
all these
But
confusing opinions.
then what then what happened is that I learned OCaml much later on. And back then, the first time I tried it, I didn't like it. So first it was Scheme. So Scheme, when I learned Scheme, so I got, that, oh God, the name escapes me of the Lambda book.
Oh yeah, the Sussman book.
Yeah, exactly. And so,
interpretation and
exactly.
yeah.
And I
Structure and interpretation of computer programs. That's ICP. Sorry,
Very nice.
It's gonna drive me crazy.
Very nice. And so the first time I got my hands on that book, I was maybe in my first year at university.
Okay.
And back then it was still in Scheme. I think they have a version in Python now that MIT does.
Oh, okay,
Python.
interesting.
But I don't know. And I discovered Scheme and I loved it. And it was, abstracting. So what I loved was the simplicity of it.
Mhm.
And then I got hooked on functional programming. And after that came OCaml.
Yep.
At first, I didn't like OCaml because I didn't like the syntax. So it was a very shallow way, shallow reasons not to like OCaml.
Yep.
And then I got hooked on OCaml. And so this is going to be interesting to a C programmer because when you're writing C, what you do basically is you write your program and then question for C programmers out there. Do you start it when it's the first time you start it? Do you start it from within a debugger
I see,
or not? And to tell the truth, like I just started from within a debugger when it's the first time I tried it because I'm pretty sure it's gonna stack full. If I wrote something non-trivial and then you spend a ton of time debugging, and I never liked debugging. And some people love it.
Oh, you're right. This probably is actually there. This is an interesting cleaver that might sort of separate the world of sort of natural systems programmers from. Yeah, it's like, would you rather just work, or is it actually kind of fun to
I mean, there are people who just love this stuff. They love to debug. They love to. You give them, the segfault file. Where is that called? The core dump.
Yeah.
You give them a core dump. They investigate that.
I don't know how little languages have core dumps. These are useful.
It's
you want
true.
to postmortem debug things, right? You want a user to be able to give you, here's the serialization of the program state when it failed. Why is it always just a stack trace?
It's true. It's a good question. It's probably too expensive when there's a VM, maybe getting the state of the VM, because I think when you have a VM, you also need, the core dump of the VM, and that might be too large.
Yeah.
I don't know. But basically what happened for me is that I was used to programming this way. And with Scheme even more so, because in Scheme, it's all dynamic. So you have to debug all the time. And the first time that got me hooked on OCaml is that I wrote something non-trivial in OCaml and it just worked, the first time.
For me, it was Haskell in 1998, by the way. But yeah, the similar thing. I wrote all this crap, and like once I got to compile, it just worked.
Exactly. And the first time this happened to me, I was like, oh my God, there's no going
People
back.
Need to know.
This is what I need now. And then I got I think I went a little bit too far with types. So I like types because they help me write correct programs. And then I started trying to encode everything with types. Yeah. And then I got to the point where I discovered dependent types. So it's like, well, wait a minute, I can have any spec I want in the type. And then I was like, I remember bursting into the office of my professor back then telling him, we're going to prove everything.
That's right.
This is going to be awesome. There will be no more
That's
bugs.
right. That's right.
It's going to be a wonderful world. And he was, smirking back. He was like, so what it is you're going to prove exactly?
Yeah.
Like,
Well,
everything.
and this is actually sort of one of the things I do, like circling back a little bit to LLMs, but not in a super hard way. Types are a kind of lightweight formal system, right? Like they're a lightweight formal method, right? They're a formal method that's kind of built into your tool chain. And so you're using it kind of by default.
Yeah.
But at some level, the type checker, that part of the semantic checking of your program passing, is a theorem about your program, right? Like is a sort of claim about. Yeah, there you go. There you go. Yeah, people are smart, man. Like lots of smart guys. One of the things that has been interesting to me about this like last 6 or 9 months is that people that I think of as extremely resistant to or extremely skeptical of, both static types, but also other kinds of formal methods, including like building lean for proofs and stuff like that. Some of them are trying to do this, and some of them are having some amount of success, right? So like mutual friend Kent Beck, who of course like is one of these unit testing people, like, has a lot to do with the fact that we call him unit test. He built JUnit and kind of popularized
And
TDD and
TDD.
yeah, and I'm sure it's one of those things with many fathers, but like is certainly one of the people who is out there, influencing people's thoughts about these things. And it's the last time I had a conversation with him, I was actually on his podcast, Still Burning, a couple of weeks ago, and he's was building a B tree and building little lean for proofs that the B tree does what it's supposed to do, and kind of feeling like that was working, kind of feeling like this was helping, even though he didn't know much about lean 4 especially, and didn't know much about formal methods especially, kind of was able to get up to speed along the way. And I'm curious, like, whether that ends up being what we expect, right? Because I mean, yeah, like you, when I review a ton of even, Fable code, right, like, there are defects, there's things where it misunderstands your intent or misunderstands what it's supposed to do, and if, like, everything we did was accompanied by some sort of proof that the things I care about are actually upheld by this program, you know, does that become a thing that either LLMs want, that their users want?
So first of all, for what I'm about to say, I think half of the employees of my company are going to want to kill me
Cool.
because they love formal methods and they
Right.
want more formal methods everywhere. The other thing is that I think formal methods is super useful. I find them even beyond useful. I find them beautiful.
Right.
Like I think, the first time I used Coq to prove that, some algorithm on an AVL tree was actually correct.
Right.
And so it was actually in the book called The Coq Art by Yves Berthaud and Pierre Castellan. So if you have,
It's just French for chicken, children. It's not.
so if you have, yeah, it's French for chicken.
Yeah,
It's not the kind of cock. It's
that's
the
right.
good kind of cock.
It's the one that ends in Q.
It's COQ. Yeah. And I think they changed the name recently.
Yeah.
And so if you haven't read that book, this is a really, really good, it's one of my favorite computer science book out there.
Right.
And I think not very many people know it, but there's something extremely satisfying in getting the proof that whatever you've written is correct, right? Now, the thing is, my experience with those things is, depending on so there are two limitations, two things that I think are going to be a problem for LLMs, because there are problems for human beings.
Yeah.
Number one, there are certain classes of problems where trying to specify them formally is actually harder than solving the problem itself.
Yeah.
So, of course, if you're trying to sort numbers or writing a B tree, like you just said, the properties are nice mathematical properties, right? So, if I want to write the spec for a sorted array, that is really easy, right? For all I, less than I plus one, and
Yep.
done. And not only is it easy, it's actually really readable. Like another human being will be able to look at this spec and go like, yeah, that's a sorted array, right?
Right.
Now, there are in B tree, we all know the properties of B trees or red black trees or whatever it is that you're trying to build. So I think for those kind of problems where you have a well-identified data structure and well-identified properties that you want to prove, those formal methods are going to be bomb and they're going to be used all over the place, probably by LLMs more than humans because it's a lot of work.
What is something crazy you believe? Like, what's something where you're not
Ah,
like on the one hand this, on the other hand that? Julian Verdaguer is the only sane man in a world that's gone mad.
I should have prepped that. I don't know. I don't know if there is something like that that I believe that is really controversial.
I think you were trying to get there with local LLMs.
No, because I
No,
don't think that's really crazy.
you're not maxed out.
I know, no.
Yeah. Okay.
And when it comes to LLMs and I don't think I have enough context. I don't think of myself as enough of an expert
Yeah.
to have those kind of crazy ideas. But no, I used to have a crazy idea,
Mm.
which was, placate a type system on top of a dynamic language
Sure.
and
That's
make
true.
that work.
Yeah. Sure.
And back then I was, for most people at the company, I was classified as certifiably insane.
It was a pretty lunatic project. Yeah. Yeah.
This was
You were like the fifth. It was like mathematicians and angle trisectors or whatever, right? Like I had a stream of people saying I'm going to put a type system on top of PHP coming to talk to me. You were like the fifth one, and like you were
Oh,
the only
I
one that
could
had
tell
good
on your
answers.
face.
Yeah, yeah. You were the only one that had like good answers to like the first question, right?
No, but
It's
I
like, well,
could
you do
tell.
this and this.
I
And you were
could
like,
tell on your face.
yeah, yeah,
It was like, yeah, kiddo, yeah. We've heard it all before.
sorry.
Sure.
I mean, you had the last laugh, so yeah.
Exactly. But no, I mean, that was definitely a crazy idea. I used to have, before that idea, another crazy idea I had was I was obsessed with linear types,
Mm.
and I really thought that linear types were going to solve the problem of garbage collection.
Yep.
And it was before Rust was popular. So I wrote this compiler called Linear ML. And so what's interesting is that I think history has proven me right. Like Rust is a thing, but I was hoping. So I wasn't hoping to only do system programming with it, and I was hoping that the scope would be much larger. And for me, when I was working on linear ML, it as I was using it, it became pretty clear to me that this was never going to become mainstream to the point that it was going to replace Java because it was just too difficult to use.
Yeah.
And I think that around that time, Rust was starting to pick up.
Yeah.
And then I looked at Rust, which had a scope that was more narrow, which was we're going to replace system programming.
Yeah.
And I looked at what they're doing, and I was like, I think that's the right approach. That's what they should be doing. And I think also what Rust had going for it was C++11 was picking up. Well, no, C++11 was Rust was already had been there a couple of years, but when C++11 came out, there was a huge boost for Rust because Rust was basically a formalization of all these principles.
Yeah.
And so, but I think, yeah, so the crazy idea I had in 2004 was, hey, we should use linear types to manage memory statically.
Right.
And then went full in on that. I wasn't the only one having that idea. In fact, you could claim that, Girard would be the first one. Girard was saying that in the 80s.
Okay.
So I actually maybe I can
Not
get
the philosopher that Peter Thiel's into, but
uh
a different Girard.
this Girard is he's a French logician.
Okay.
And so he is the one who invented System F. So I don't know if you heard of System F.
I do know of it, but it's a deep cut. So like, why don't you bring me back up to speed?
So yeah, so maybe I can explain to you. So basically, when there was first lambda calculus, right?
Yeah.
And lambda calculus, Church came up with a very basic type system for it, which
Yeah.
we now refer to as simply typed lambda calculus. And that type system for lambda calculus was very restrictive. Like you could barely type any program with it, but it was just checking that the shape of things was correct. And just writing a fixed point operator with it was already out of the reach of what the type system could do. And then so there was a stream. There was all sorts of people who worked on building more expressive type system. One of the famous one is the one from Gödel called System T, and System T was a good extension. And the main thing that they were trying to do is add looping and add a fixed point operator that works.
Sure.
And when Gödel did that, the people started looking at it and thinking, well, is this expressive enough? And that's how they came up with the Ackermann function, which we now know very well. The Ackermann function was there to show that System T, good old System T, was not expressive enough to express all sorts of looping. And basically, there was a lot of back and forth, there was a lot of trial, and it all basically finished with System F. And System F was basically what's still considered today, I think, the most expressive type system for lambda calculus, where you can pretty much express whatever you want. And so that was one of the main contributions of Girard. But after that, he worked on linear logic. And linear logic, for those who are not familiar with it, is basically something where it's a different kind of logic, because whenever so how can I talk about this? Basically, what you can notice is that if you use natural logic in certain circumstances, it will lead to incorrect results. And usually the way that happens is whenever you talk about resources, right? So let's take a resource that everybody knows. Let's take money, right? And I'm going to make statements that involve money, right? So I'm going to do the classic thing of A implies B. So I'm going to give A is going to be a statement, B is going to be another statement. And I'm going to say A implies B. So let's say A is a statement, I have $2. So you have $2 in your pocket, a statement A, right? Then B is the statement about what you can buy with it. So let's say I can say B is, I can buy a chocolate bar, right? Then I make another statement, C, which says, I can buy, chewing gum, right? So if I follow the rules of that natural logic, if I were to say A implies B, which is if I have $2, I can buy a chocolate bar. Let's say this was true. Then I have a second statement that says A implies C. If I have a chocolate bar, I can buy chewing gum.
That'd be B implies C though, right? Oh, if I have a chocolate
No,
bar.
A implies B, A implies C. Okay. If I have those two things together, in natural logic, I can deduce that A implies B and C.
Okay.
So I can deduce that if I have $2, I can buy a chocolate bar and I can buy a chewing.
I'm following.
And that is obviously incorrect. I mean, you can go try it out at the gas station and show them your little reasoning. They're gonna say, "No, sorry, get out of here." We're not giving you those two things. And the reason is $2 is actually a resource. So whenever I write, if I have $2, I can buy a chocolate bar. Whenever that statement, that implication has been used in my proof, it has to consume the $2, right? And that's what Girard was interested in. And he developed a logic for that. But his secret plan was not to manage resources. Well, it was. He was particularly interested in a particular kind of resource, and that's memory. So basically what happened is he developed a logic where all implications are changed, modified to have linear implication. And a linear implication consists in taking the statement and consuming it. So now when I write A implies B, if I decide to use A has now
used up A.
used. I used up A.
Okay.
So now I cannot go back and use it for something else, right? Now, how do you express? It's actually strictly more. So then you have operators to say when you want to duplicate A or shrink A. And because, thanks to those operators, you can actually express all of natural logic.
Okay.
Because in natural logic, all you have to do is say, duplicate A enough times explicitly, and then you'll be able to deduce all the things you would have deduced in natural logic, right? So it's strictly more expressive than natural logic. Then at this point, you're probably thinking, what is the relationship with, memory?
Right.
Where are we going with it? Right. And so the thing is, so I have to jump to programming through Curry-Howard. So for those who are not familiar with it, Curry-Howard is a bijection that was discovered in the 70s that basically says that a type is to a program what a theorem is to a proof. So what that means concretely is that whenever I tell you, hey, I have a function, it takes an A and it produces B's, and you with your little fingers write down that function, you are actually doing exactly the same thing as if I told you, hey, I have a theorem that takes A's and produces B's. Can you write the proof? Writing that proof is the same job as writing the function. And the good example to convince yourself of that is to take basic examples involving implications. So we can do one together so that you get the idea. So let's say, you know, I have A implies B and B implies C, right? And I want you to write me something that's a proof that A implies C. I want you to write no, wait, you have A implies B, B implies C. And well, actually we can do simpler. We can you take an A, you take a function that given an A produces a B, and you have to produce B's. So let's say you were writing that function with your little fingers, right? Your first parameter is an A, your second parameter is a function. Well, what you would do is you would apply the A to the function and return that result, right? It turns out that this exact thing that you're doing has an existing rule in a proof theorem that would be called modus ponens that does exactly that, right? So I can take your program and derive a proof from it. The only thing you have to remember is proving that A implies B is the same thing as writing a function that takes given an A produces a B.
Right. That's a really interesting. Usually, like when I ask people for like something crazy they know or know is true, it's sort of a hot take, basically, right? They're sort of like, well, you know.
So I didn't have a good hot take. So what I did is I took the hot take of somebody else in the past, which I thought was really cool. And
No, but you did real effort on it, right? Like you actually like committed a chunk of your intellectual work.
That is true, but it wasn't really my hot take in the sense that there were people who were, you know, already believing in that. But yeah, I tend to do that though. Once I have a hot take, I tend to just go, oh no, I have a hot take.
Oh, here we go.
I think reactor programming is going to be a very important part of the success of LLMs, especially in the field of coding. And so my hot take, well, and I'm putting my money where my mouth is, obviously, because I'm building all the ecosystem to make that work. But basically, my take is LLMs will need to train on larger systems. And to train effectively on larger projects, they will need to be able to iterate on those larger projects faster. And so the latency of the tooling is going to become the bottleneck. And so right now, I think nobody cares yet. I mean, a little bit like Anthropic bought Fun, I think that goes in that direction, that they start to think, maybe we should own some of that tooling to help, you know, the feedback loop of the LLM. But I think it's going to become apparent, much more apparent once we want to train LLMs to do much longer tasks and work on much bigger projects by themselves. So right now they perform tasks on large projects that they usually didn't write themselves. But once we get to the point where we want an LLM to write a 5 million line code in a 5 million line code base and maintain it themselves, once we get to that point, then to train those kind of models well, you will need to run experiments. And if every time you run an experiment, you have to wait for Circle CI for 30 minutes, the training is not going to be very fast. So if you take all of that and shrink it, and what I mean by all of that is really the whole thing. So what I mean is the first step is obviously type checking and linting, all these things. That has to come back fast. Once this comes back, then you need to do static analysis to figure out which tests you have to run and only run the tests that matter. Once the test passed, you will have to also make the program itself incremental so that you don't have to restart everything, fill up all the caches and everything. Invalidate, you know, just the parts of the code that needs to be invalidated and recompute only the parts of the cache that needs to be computed. And then if you can do all of that, which is what we are building at SkipLabs, so you can do all of that.
Problems in computer science. So yeah,
if you can do all of that, then the change whenever you're doing so another thing that's going to be important, I think, is the ability to branch. So you want your memory to be you want to be able to run like 100 experiments at the same time.
And kind of like copy on rate fork, the
Exactly.
big thing
Yeah.
underneath it. Yeah, yeah.
And so once you have all of that, that means that when the AI wants to try, let's say 100 different things that would have taken half an hour each, and all of that takes, sub-seconds, that the model who has this kind of tooling will beat all the other models.
Right.
And so, but it's the history of optimizing pretty much everything. There's always, a bottleneck, and then all your resources go on that bottleneck. And you only start investing in the next bottleneck once, things when you basically get to it.
Yeah, yeah.
And so I think we haven't actually gotten to it yet, but we will get to that point where the bottleneck is the tooling. And when that's the case, then the latency of the tooling is going to be the key. And the only way to build tooling with low latency is with reactive programming.
If you met a 19-year-old version of yourself, except it's 2026, and you're yourself, and you're brilliant, and you're in France somewhere, you're a brilliant man, seriously. We'll skip over the false modesty. Um, and you got a lot of potential anyway, and a lot of opportunity, and you love all this stuff, right? You're really interested in PL, you're really interested in computers, you're really interested in like computers, the machines, but also computers, like the kind of conceptual frameworks that are unlocked. What would you advise that younger version of yourself today to go do? Is it still just like do your informatics degree, you're on the right path, keep going? Or does something about kind of this, whole LLM milieu massively change the right way to allocate your energies?
Yeah, I don't know. I mean, we're talking about a younger version of myself who would be young today, who would be
That's
starting.
right. Yeah, yeah. So you're 2026,
Okay, and I'm
Julian, young
19
Julian.
and 2026. Yeah, so I would definitely add more time, working on data science and spending more time figuring out how all this stuff works.
All this
Uh,
stuff being like kind of machine learning
yeah,
or
machine learning. Yeah, figuring out how machine because I came pretty late in the game for these kind of things. Like I learned seriously about them in 2016, 17, something like that. Um,
I
and
noticed you waited for me to leave FAIR before you started working on it. Thanks, man.
yeah, I
I appreciate
actually
it.
joined Fair after you left, so that was interesting. There was a time where I was thinking joining Fair in 2013, right after Hack, where you were telling me all about this cool stuff happening at Fair, and I was very curious about it. So I would definitely tell the younger version of myself, go learn what Transformer is, how this stuff works, go build an intuition, because that's the stuff that takes the longest time. Because, for example, when I joined Fair, the way I like to learn things is usually by rewriting them.
Yeah.
So the first thing I did is I rewrote a framework for, AI and rebuilt uh, an autograd and all that stuff because I wanted to
Yeah.
understand how all the formulas were working.
I had to make AutoGrad in C++, right? I had to make a template system where it's like these things are, and then you just, I don't think anybody ever used it for anything. I hope they didn't use it for anything. The point is like, we're engineers, we learn with our hands. You kind of have to make stuff to know.
Same instinct, but basically what ended up happening is that I do know how these things works and I don't, in the sense that I do know what steps needs to be taken to get a transformer to work, but I don't have a good intuition. I have a little bit of an intuition of why it works and why not, but I think what takes a very long time is to build an intuition where you know what kind of things are going to improve the model, for
Yep.
example.
Yep.
And that takes time. So tell my younger self, go educate yourself on that and become better at that.
Along those lines, like when I started doing this stuff at Fair, I think that part of it felt unlike any other kind of computing to me.
Yeah, that's true.
Like when I remember I was working on a word embedding model that was sort of inspired by Word2Vec, but it was like we're going to use hashtags as supervision. So it's sort of a bilinear embedding system. We're trying to minimize the distance between a bag of words and the hashtags it co-occurs with or whatever. And like ran on CPUs and stuff, like very simple thing, right? And I kind of had something kind of working. You know what I mean? It was kind of like you'd put in a tweet and it would kind of like get a hashtag that sounded plausible some of the time. And then we hired Jason Weston, right? We brought Jason Weston in, who's like a great NLP guy, already very experienced at the time, now even more so. He's done a bunch of amazing stuff since then, of course. But he kind of like looked at this and was like, yeah, this is a cool project. This should be better. Like for all that you're looking at and all the parameters this thing has, this just like should be more impressive. Try like these 7 things. And it was kind of like one of them was like, clip the vectors to the unit hypersphere and, do use this learning rate schedule and well, and a couple of other things, right? And like all helped. And you could do it in one step. It wasn't sort of like sit there and like retrain for the first one, retrain for the second one. It was all just like an improvement. And it was almost, and it reminded me, I kept using the analogy of like, it's like a chef like tastes your chocolate chip cookie recipe or something. And it's just like, you need more butter, you need more salt. Oven needs to be hotter, but then at the end you should add some water or something, whatever, like crazy stuff. And you do all the weird stuff they say, and it comes out way better. And it's not a digital kind of way better. It's this weird analog kind of way better where just like these results are subjectively much more impressive. And it's still kind of like this. I mean, we know more about the underlying math. Like we know, you wouldn't just like clip to the hypersphere now. There's like smarter ways to do it and everything. Um,
Distributed systems are a bit like that too.
Actually, it's a good point. That's a good example. That's a good example.
People who are good at that stuff, they will be able to architect something from the get-go that's just going to be much, much better than somebody who hasn't been bitten by those problems before.
We can still build like a TLA plus model though. Do you know what I mean? Like there's still things in distributed systems where there's like a digital notion of correctness that saves your butt. The performance part of it's true. There's a lot of taste and a lot of intuition around getting it to run well.
And it also feels the same that when they want to optimize the performance, oftentimes they run experiments.
Yeah,
So
yeah.
it feels like experimental science, right? Where they run experiments. And in fact, performance work in general feels a little bit like that because the
That's true.
hardware is so complex now
Yeah, yeah.
that, nobody really knows what's going on in there. So you have to treat it like, a black box and run experiments. And
Including the people who made the hardware, right? The hardware
exactly.
is so complex it has weather. The hardware is so complex that it gets into states.
But there's still people with good intuition,
Yeah.
good taste who will know this kind of stuff is more likely to work. So it's not going to be a hit 100% of the time,
Mhm.
but they will tend to have better ideas than, the layman who just
Yeah.
doesn't know anything about
Yeah,
it.
yeah.
So it feels to me that I would have liked, if I was starting software today, I would try to build that taste ASAP for, these kind of systems or anything related to AI.
Yeah, yeah.
And then I don't know. I mean, there are some people who say that you shouldn't, learn programming, pick up programming. Um, I don't know about that. Like I think pretty prominent people in that space have said that, learning how to program is useless now.
Yeah.
I then again, I'm super biased because I like to program, so maybe I'm wrong and I'm just not acknowledging my bias, but I find it hard to believe.
Yeah.
I still think that we're pretty far from, having the LLM just completely takes the jobs of all the
Right, right.
programmers out there. What I think is much more likely is that programming is actually going to become much, much more interesting, where you have an army of LLMs, an army of agents that are working for you, doing all the grunt work that nobody liked doing, like
Yeah.
refactoring and, cleaning up some stupid stuff that anybody could do. It's just very time consuming. It will also help, try out ideas. But I think that at least for the foreseeable future, I don't think it's going to replace the engineers.
Yeah. Yeah.
But again, I've underestimated LMs before, so I'm not because in my book, I think we need a breakthrough. I think I said it in another. I've said
Yeah,
it
yeah.
many times. I think we need another breakthrough like Transformers were,
Right.
or like what or this kind of breakthrough to something that really changes the game to get to that last step. And many people think, no, if we just keep on pushing LLMs, we'll get there.
Yeah.
So I don't know. Is it good advice to tell someone today to learn how to program?
My best guess is still yes, to be honest with you. My best guess is that like even if so one of the things I've observed with people using coding agents and LLMs and these other kinds of, massively overpowered, super high leverage software construction tools is the more I think of somebody as having already attained real mastery of engineering as a craft and science, the better they're able to use these tools, which is not a priori what I'd have expected, right? Like you might have expected that it kind of lifts the floor, but the ceiling is wherever it was.
And it goes both ways.
Yeah, yeah,
Those who were mediocre engineers are much, much more mediocre now because the LLMs are basically LLMs are like steroids. So they'll supercharge whatever you are, right? And so if you were mediocre and you were pushing out shitty code, well, now you're pushing out a ton of shitty code. That really sucks for everyone. And if you were a good engineer pushing out good code, then now it's like leverage, right?
Yeah.
That's what the LLM does.
it's an amplifier.
It's an amplifier. And so it's true that I would tell people to go learn how to program, but I would put a caveat in it. I would say, if you're truly passionate about it, because what I mean, you probably heard this rant before when I joined. Uh, um, uh, I was at Facebook and I was frustrated. So it was late stage Facebook, and I was frustrated because there was a lot of people who I was interacting with who didn't care about something relatively geeky, but some programming stuff, and who like, dude, and I was telling you, I'm frustrated because, imagine you're a kid and you like to play basketball, and your whole life you dreamt of playing basketball, and you finally make it to the NBA, right? And you're in the big leagues, and and you have a plan. You want to talk about things. You want to talk about new ways about training, about new ways of this, new ways of that. And the rest of the team, bar maybe one, is like, dude, we're just gonna throw the ball in the basket. All right, nobody gets the fuck. This is just a game. We're just going to throw the ball. You're annoying us with your new techniques. Nobody cares, right? And there was a lot of that happening in software in Silicon Valley, because there was a lot of people who chose the job because it was a well-paid job, right? And so I think now with LLMs, having this kind of attitude is going to be very, very risky. So if you go into software because you think that it will be a well-paying job, but you're not really passionate about what you're doing, I would say be very, very careful, because what's going to happen is that if you're looking, so typically if you're not passionate about something, what you're going to do is you're going to try to find a niche where you get to do always the same thing. And
that's all going to get automated away.
Exactly.
Yeah, that's all
in
going to
the day and age of
It used to be you could have a whole career that was like, I'm the build system guy. I know everything about Make. I know everything about CMake.
Exactly.
But maybe there's some newfangled build systems. Do they even work anyway? Who knows? I'm the Make and CMake guy.
Exactly.
And that's what I do for this company, and it's enough, right? And I think that kind of is structurally never going to happen again.
Exactly. So my advice would be, if you are truly passionate about it, and in which case my advice is completely useless, because if you're truly passionate about it, you're going to do it anyway. And, I mean, that's why I started computers. I started programming because I loved it.
Yeah.
And back
So in the 90s, like computing was a subculture, right? Like
yeah,
I used to...
back then, nobody would think that you would make big money out of it, especially in France. It was more seen like a subpar engineering field where you would, nobody saw this as a smart career choice. At least not when I started, like in the 80s when I was a kid.
Yeah.
And I think, yeah, so the same should apply here. Like the right question to ask yourself is, would you do it anyway? If the answer is yes,
Yeah.
then you are, you're in a great place. And the same is probably true with music. There are other things like that I think you should only start if you're passionate about that.
Yeah.
Because if you're, so one of the difference with music though is, if you started for the money, well, that's probably a bad idea. The people who are passionate about it are probably going to be so much better than you at it,
Right.
that you're not going to find, a good job, and you won't be able to make a living off it. And I think now computer science is probably going to become like that. Computer engineering. It used to be that we needed so many little hands to write these little shitty things that there was space for a bunch of people who didn't care.
Yeah, you'd have your 10 million line code base at your gigantic company, and there'd always be some project to move from this data store to that data store. And it was like some director somewhere has an army of people who are, doing nothing but doing these relatively mechanical migrations. And if that project was going slowly, that director could ask for more people and probably get them, and so on. Yeah.
Yeah, and actually, my theory is that directors love to have useless projects. So I've worked in enough big companies now to know that the director wants a big head count.
Yep. I mean, that is actually, and in fairness, that's the measure of impact,
That's
right?
the
Is you
measure
have a
of
span of
impact.
control if you're a manager, and if
And ideally, the problem is when you have people and those people are doing real work, it creates friction because real work means change and people are reluctant to change. And so it will create human friction that you then have to cut oil on, which is basically the job of the management chain, right?
Yeah.
And so ideally, if you're a director and you want to grow your org, the best thing to do is to uh, hire as many people as possible to work on something useless
Right.
that you've convinced upper management that somehow was useful.
That's right.
And that is the idea. That's where you want to be.
We have this class of bugs that we've had in the past. They've really hurt us. It's because we're on data store Fribble, and we need to get to data store Boggle to
Yeah,
get. And once we get to
yeah,
Boggle,
exactly.
this whole class of bugs goes away.
Or
It's
a
just going to
rewrite.
take millions of lines of code.
Yeah,
or
or
yeah,
a
rewrite
rewrite.
would also be acceptable.
The
Yeah,
rewrite
that's right.
is also a good one. And
The Rust rewrite that's happening in
usually, so
thousands of
you
shops
can
right now.
have a Rust rewrite that makes sense. So, for example, the one that Bun did recently, they had a bunch of memory bugs. You switch to Rust, you don't have them anymore. That makes sense. But when you go from a safe language to Rust, and that safe language didn't have performance issues to begin with,
Yep.
you're like, why are we doing this again? And it's not going to be done. The plan was not to do it with an LLM.
Right. Yeah, that's true.
Have an army of people doing that.
For those that have not followed the ripped from the headlines Bun reference here, as it used to be in Zig, they landed a Rust rewrite as
In
a
one
single
PR.
PR. That's what you know. Okay. So probably to the chagrin of some open source contributors, I imagine, that might have had a PR open, LLM authored or otherwise.
I mean, rebasing
Yeah,
after
rebasing
after that one is gonna be it.
I guess you let the LLM rebase it. You let the LLM figure out how to express your intent in Rust.
So and so for directors, I mean, talking about bad incentives, they have those really weird incentives that number one, they need to get as many people as possible because that's how that's how they make more money, and so they have an incentive to hire more people than they need, and then they have an incentive for those people to do things that are going to cause as little friction as possible, which usually means to work on things that are as not disruptive and that are useless.
Yep.
The more something is useless, the less people argue about it.
Yeah.
And
for those listening at home, by the way, Julian and I have worked at some big companies before. That does tend to be a little corrosive to your idealism about what a job in technology can be like over time. I do want to say, like, there is good work that happens there, and there's good teams that do awesome stuff there. Well, thank you once again for joining us, Julian. It's been an honor and a privilege. Next time will probably be virtual, unfortunately, but we'll have to do this again. For those of us for those of you that listen this far, thanks for listening, and remember to smash like and subscribe into the stratosphere, like Jose Canseco wrote it out of his mind.
Of course.
And hope we'll see you next time on Computers, Coffee, and Beer.
Thank you.